exponential function base a, the function is f of x equals to a raised to the x power. Do you still remember that like before we introduce exponential function, the function that I use usually like x raised to the second power, x raised to the third power, fourth power, or the square root of x. So in the past, we have x, which is the base, and then the exponent is a real number. So let's say x squared, the base is a variable, the exponent is a real number. So this time we have the other way around, the base is fixed, is a real number. And then the exponent is a variable, and then in this exponential function, a is always greater than 0. A is not equal to 1 because when a is equals to 1, we don't care what the x is, right? So f of x is always equals to 1, so that's why we have to omit 1. But a is positive, and then x is a real number. So for example, 2 to the x, 3 to the x, 4 to the x, 5 to the x, 6.72 to the x, they are all exponential function. And then in this video, I would like to compare the graph of f of x equals to 2 to the x and 4 to the x. So what happened when you use a bigger base? I have a picture, but before we get into that, let's take a look at the table value. So for the 2x, I'm going to match the color. So 2 to the x, when x is equals to 0, let's take a look at what I have right here. So when x is equals to 0, 2 to the 0 is 1, x equals to 1, 2 to the first power, 2 to the second power. So as x increases, y increases exponentially. What happened when the base is bigger? So when the base is bigger, as x increases, y increases way faster compared to the smaller base. 4 compared to 2, 16 compared to 4. So as x increases, y increases exponentially, but the rate of increasing is much greater than the smaller base. Now, what we need to see is what happens when the exponent is negative. So when the exponent is negative, we have 2 to the negative 3, negative exponent 1 divided by 2 to the third. So you put the big number in the denominator. As a result, this quotient is very small. And then 2 to the negative 2, 1 divided by 2 squared, that is 1 over 4. And then 2 to the negative 1, 1 divided by 2 to the first, which is 1/2. What happens when you use a bigger base? So when you do a negative exponent, 4 to the negative 3, this is 1 over 4 to the third, which is a 64. So compare 1/8 and 1/64. Do we agree that the 1 over 64 is much smaller? All right. 4 to the negative 2, 1 divided by 4 square, 1 over 16. So compare 1 over 4 and 1/16. 1 over 16 is much smaller. And then 4 to the negative 1, and then you have 1 over 4 to the first, which is 1 over 4. So every one of these is an ordered pair. I can draw a few for you. So when x is equals to negative 3, we have 1 over 8. X equals to negative 2, we have a quarter. X equals to negative 1, we have a half. X is equals to 0. Y is equals to 1, 1 comma 2, 2 comma 4. And then how about the blue, the 4 to the x? So this is negative 3, 1 over 64, negative 2, 1 over 16, and then negative 1, a quarter, and then 0, 1, 1, 4, and then 2 comma 16. All right, so you plot these points, and then you connect the points, and then you will see two curves. So I have the curve right over here. So we have 1 for 4 to the x, so the blue one is for 4 to the x, and then the red one is for 2 to the x. Now, what do you see here? So the first thing I see is for the bigger base y, so which is 4 to the x. So as x increases, the first thing that I see is the function increase really fast. Do you see that once x greater than 0? So as x greater than 0, so as when x is greater than 0, the function of 4 to the x goes up much faster compared to 2 to the x. How about when x is less than 0? So when x is less than 0, on the left-hand side of the y-axis, do you see that the blue function decreases so much faster compared to the red function as x goes to negative infinity? And then for both functions, the domain is all real number. You are choosing an exponent. You can choose whatever you want, positive, negative, and 0. The range for both functions, they are above the x-axis, so that means y is greater than 0. There is no y equals to 0, because y equals to 0 is a horizontal asymptote, and they both have 0, 1 as the y-intercept, and they are both increasing function. The horizontal asymptote is y equals to 0, which is the x-axis. On the picture you see here, I use a dotted line right here. Y equals to 0. So as x goes to negative infinity, both function approaches to 0. So that is the comparison of 2 to the x and 4 to the x. So what happens when the base is bigger? Now, for exponential function, in general, we have an increasing function, and then the y-intercept is at 0, 1, horizontal asymptote. Y is at y equals to 0, which is the x-axis. As x approaches to negative infinity, the function approaches to 0. And then the whole function is an increasing function. Alright, so that is the end of this video. If you like the way I introduce exponential function, give me a thumbs up, a subscribe. I will meet you all in the next video. Signing out.